Why learn Python? Because different programming languages are used in different jobs. Certain programming languages are sometimes just better at certain jobs, and some are just more historically used for other jobs. Python is used in many, many things. There are a lot of things that use Python. It's also an excellent first programming language to learn because it's easy to get started and the syntax is fairly clear, unlike C++, which I also teach, and is considerably harder for a beginner. Python is really popular. According to the TIOBE index, which tracks the popularity of programming languages, Python this month is the 5th most used programming language for professional programmers. And it's on the way up. The languages in front of it are C and C++ and Java, and C# just a little bit ahead. But C and C++ and Java are all on long-term declines. Python is on a long-term increase. Python is used to create web applications. So things like CCC confer, not the part that you download onto your computer, but the part that you sign into, got maybe Python. Google App Engine, Amazon Lambda, and Microsoft Azure can run Python programs using a thing called Platform as a Service. Platform as a Service, as an aside, is when you upload a program to the cloud, and your program gets run directly. This class is called Cloud Programming in Python because I'm going to show you how to use those public clouds to make it so that you can run your programs independent of any of the machines that you use for free, by the way. Here's an example. Wait as my container spins up. This is a streaming music website where my wife puts her DJ mixes. Her taste in music is somewhat harsh. This is written in Python. This streaming application I wrote for her so she could have, when you have a DJ wife, you're gonna have to listen to a lot of music. When you have a programmer husband, well, you're gonna have your own custom DJ site. If you go to my GitHub and you find my mix player repository, you can look at this. Application, playlist.py. This is 144 lines of Python, and it is all that you need to have a fully operational streaming player of your own. Completely custom. This runs on Google App Engine. Anybody want to guess how much this cost me a month? Kyle? Zero. Kyle knows how cheap I am. When you run software as in this way, in a platform as a service way, you get billed by call. So every call I make into Google's infrastructure, every time a web browser hits that page, I get billed for one hit or one call. And I can do hundreds of thousands of them a day before it costs me anything. So one of the things we're going to do in this class is you're going to sign up for these one or more of these cloud providers that are going to let you upload a program to them and then host that program on your own website if you like. And as long as you stay underneath their usage limit in the free tier, you'll never have to pay for it. By the way, if any of you guys decide you're going to try and distribute a denial of service attack, my wife's streaming site, curse you. But what's going to happen as soon as we go past the free tier, it'll bill me up to $1, and then the site shuts off until the next day. So you could cost me up to $1 a day. By the way, none of this Python is particularly fancy. Many of you after this class are going to be able to look at this and say, really? That's all he did? In fact, for those of you who are wondering why the password for this class is Flask on the streaming or on the Zoom meeting, it gets its name from this, Flask, which is the framework I use to make this web application. It's a framework we're going to use in this class. Python is one of the core languages of robot operating system. The other core language for robot operating system is C++. There is another really key part of making robots called OpenCV, Open Computer Vision, that is also using Python as a core language. So why, now it might be a little bit more obvious for those of you guys who are here in class, why there is a robot in class. So what you're seeing is this GUI running on my laptop is seeing through the eyes of my robot. This robot, you can see in the upper right, you can see the GPS readings that are coming from this robot. That cube you see is showing you the robot's orientation. Never want to see red, always want to see blue. And the 3 lines just below the picture is the reading coming out of the sonar. The sonar, if you look at this robot, so those of you guys on CCC confer, the blinking green lights, that's the sonar. The sonar makes it so the robot doesn't bump into things. Python is a language that is used for a lot of scientific and numerical computation. So this project called SciPy, Science Python, has a bunch of Python libraries that are used to do things like calculate the number pi to 10 gazillion decimal places, or graph and analyze scientific data. One of the reasons why I chose Python to bring a Python class to bring here is because folks in the astronomy department were saying, hey, you know, all the astronomers out there, they're using this crazy language called Python. When are we going to teach that? And I was like, well, I'm glad you asked. The new generation of Cisco equipment. So how many of you guys have taken 81 or are in 81? So you guys are learning Cisco's iOS command line, right? Well, the command line is a really important thing to know, but the command line is also not the way that corporate networks are going to be configured into the future. And the reason for that is that if you have a large corporate network, you might have 5,000 routers and switches. You can't just send a technician to go plug into all those routers and switches and enter iOS commands. The future of network infrastructure is going to be programmable, and the core language for programming the next generation of Cisco routers and switches is Python. Okay, so hopefully you guys are fired up about learning Python. Let me talk a little bit about the class. In the class, we're going to be using Cloud9 IDE. So you don't have to install anything on your computers because everything we're going to do is in the cloud. And it will help you to have a little bit of knowledge of Linux. So Cloud9 IDE is this page, and I'm going to go through and get you guys signed up and ready for it in a minute. So each one of you is essentially going to have your own Linux virtual machine, or really a Linux container, to use in your Cloud9 IDE project. So you don't need to own your own computer. Of course, many of you probably do. You can use the computers here at school. It'll be perfectly useful for you. You can borrow a computer. You don't even have to install anything on it. You're just going to use Cloud9 IDE. You are not expected to have ever programmed before. If this is your first programming class, you are in the right place. So I'm going to go through programming from the very basics onto what you need to actually put together a real program. But I happen to know that some of you have programmed before. And if you're asking yourself, but I know 7 languages already, Bash scripting. If you have already programmed before, you will not be bored. Partly because I love to torture myself, but also mostly because I want all of you to be able to be engaged no matter what your skill level is. There are going to be kind of like 2 tracks or 2 layers in this class. If you are a beginning programmer, you're going to do all of the first part of the class. I'm going to go through all of the real basic essentials that you need to know. If you go through that and you want more to do, or if programming basics you are already kind of past in your skill level, there's going to be lots more in this class that you can do to keep you busy to learn more about cloud programming. There's also going to be a few things that I teach twice. Once at the beginning in the advanced track, and then once at the end for those of you who are just learning to program. My goal is I don't want to lose any first-time programmers because you kind of hit a wall and things got too hard. And I also don't want to lose any of you gray-bearded software engineers because it's boring to learn if statements because you already know them. Okay. You're going to need a copy of this book, The Learn Python 3 the Hard Way, because there are exercises in this book, and we're going to be doing those exercises in class. I picked this book because I like the exercises, for one, and for two, it's pretty cheap. I think the paper copy was like 25 bucks, which is unusually cheap for a textbook. Now, if you are a first-time programmer, if you're a new programmer, this isn't going to give you the kind of background and the theory that you might need to be successful. So I really strongly encourage any first-time programmers to buy the somewhat more expensive Starting Out with Python or borrow a copy, because that particular book is going to give you a little bit more detail. It's going to give you a more wordy introduction to what you're doing. Now, I think I have a slide about this in a second. The first time you learn to program, it's usually pretty intensive. And so first-time programmers need a lot of practice. Practice, practice, practice. Typing things into the computer is the kind of practice you need when you're a first-time programmer. And the Learn Python the Hard Way is a book that really focuses on giving you the kind of practice you need to train your mind and train your fingers to program like a pro. Let me check the time. Okay. Okay, so what the heck is cloud programming? Well, when I learned to program, in fact, I learned to program on a machine just like the one pictured, an IBM PC Junior with 128K of memory and 1 floppy disk. No hard disk, by the way, in that machine. In the old days, programs ran on a single computer. You wrote a program on the computer, you compiled it on the computer, and you ran it on the computer. And if you liked it, you copied it to a floppy disk and you gave it to someone else. Computers were not expected to have a connection to the internet, and everyone learned how to do programming on the command line. So that time is long gone. The overwhelming majority of programs that are written today are expected to run on demand. So you notice when I went to my wife's streaming site, which I might still have loaded, the first time I hit it, and after a little while, it takes some time to load, because this program isn't running until you visit the page. Google does that to save me money, or really to save them money. No resources are being used until someone comes to the page. Now, if I reload the page, notice it reloads pretty quickly. It's because the program is running. Programs today are expected to run on demand. They shut down when they're not needed. They come back up when they are needed. Programs are expected to run on multiple devices. So whether you're using the program on a browser, whether you're using the program on a phone or a tablet, the program is expected to run basically the same way, or at least expected to run well on multiple devices. And programs are expected to maintain global consistency, or maintain be synchronized everywhere. So if I send an email on my phone, I expect to see that email in the sent messages on my computer. In this environment, the command line, while still very useful, is not as useful as it used to be, because you don't necessarily know what computer your program is running on. In fact, most of the time, you don't really care so long as it is running. And really importantly, cloud programs are expected to be fault tolerant. So in other words, if the machine that my streaming site is running on crashes, there may be a disruption in service, but that disruption should be short. The program should recover, come back to life, and keep serving its users, even in the event of a hardware failure or some other kind of failure. And that makes different forms of storage necessary. So because you guys are learning, we're going to talk about storing, reading, and writing files, because that's a really important skill in any programming language. But we're also going to talk about reading and writing databases, because databases can maintain the kind of global consistency you need to be able to have a fault-tolerant application. And so this class is going to focus on teaching programming using modern cloud-based tools and techniques. So same programming is kind of programming, but you guys are going to learn the tools that are going to be much closer to the tools that you're going to use if you go out and make a living programming. And so hopefully when you go do that, you'll already be in the mindset of how cloud programs work and what you need to do to write them. All right, so I want to talk about Python versions, because some of you have already bumped into Python 2 and Python 3 problems that we've had. So there are really two currently supported versions of Python. Python 2, which is 2.7.13, and Python 3, Python 3.6.2. Programs written for Python 2 will generally not work on Python 3, and vice versa. Now, that's bad. That, as a programmer, that's really like breaking your heart, right? Because you want to be able to write your program once and run it everywhere. Well, if you write your Python 3 program a particular way, then it will run just fine on Python 2. And I'll show you where you have to know what the difference between Python 2 and Python 3 is. I'm going to show you where. And the reason that it's important to know those differences is because if you're doing cloud programming, say you're starting a new project, you really ought to be doing Python 3. But if you're using Python to control that robot over there, well, you have to use Python too, because that's what all the libraries are. So it's important that you know how to navigate those differences. In class, we're going to focus on Python 3. I picked Python 3 the hard way for a reason, because all new programs should be written in Python 3. We need to put Python 2 away, because there's a lot of things about Python 2 that got fixed in 3. Now, it is very, very rare for a programming language to go through such a dramatic change. In fact, there are very few instances in history of any programming language going through an incompatible breaking change. Perl 4 to Perl 5 was an example. Everybody had to write a new variant of Perl. It was decided amongst the people that write and maintain Python that that pain and that drama was worth going through in order to fix some very long-standing broken things about the Python programming language. And unfortunately, you guys are hopping in right when the family's going through a divorce. That's okay, because we're going to stick with Python 3. You'll get the new stuff, and it'll be all right. Here's another thing, in case that last segment of class was not awkward enough. Yeah, most things are still running on Python 2.6 and 2.7. Well, real life is about to catch up with where the Python community is going. And like I said, it's not that hard to make your Python 2 programs compatible with Python 3. You just got to go and do a little bit of work. So I want to talk a little bit about programming languages for a second. Just hang out in lecture mode for a second, and then we'll compile Python. So broadly speaking, there are two types of programming languages. Programming languages that are said to be compiled languages, and programming languages that are said to be interpreted languages. A compiled language is one where you take source code, like this source code, which is Python-like, and it is parsed into an intermediate representation that actually looks like that if you were to draw it schematically. Intermediate representations tend to be what is known as a parse tree. This is a representation of a parse tree. In fact, this parse tree exactly represents this source code. And then it is compiled into machine instructions. Those machine instructions are specific to one particular processor. So if you compile something for the ARM processor, the Cortex A15 that is in my phone, then the program is only going to run on an ARM Cortex A15 like the one in my phone, and maybe newer versions of the same processor. If you compile the program for an Intel-based processor, that program is only going to run on Intel-based processors. C, C++, Swift, and Go are compiled languages. So many of you guys know C and C++. Swift is Apple's new programming language. And Go is Google's fancy pants new programming language. Go is pretty awesome, by the way. I've written some Go. An interpreted language works similarly up front. An interpreted language is where your source code is parsed into an intermediate representation called a parse tree. But then instead of compiling that parse tree further, the Python program just walks down the tree. The Python program walks down that tree, and when it sees a command that you've created, it goes and does what you've asked. And an important difference here is that you need the Python program to run a Python script. But you don't need the C compiler to run a C compiled binary. Java, Python, Ruby, C#, Visual Basic, PHP, JavaScript, Perl, and most of the other programming languages in the TIOBE index are interpreted languages. TIOBE. I don't know what it stands for. Maybe it's a proper name. Oh, so it's a property name. The Tiobe Index. They do a poll of a bunch of nerds they know, I guess. They never call me, I don't know why. And they ask them, have you started a new software project in the last month? And if so, what is the language that you're coding in? And then they take that data and they create a ranked list of the most popular programming languages. And there's a lot, if you really want to know, like programming languages, you go down on this list, you go back into the, number 50, ladder logic. Logo! That's the first programming language I learned to use on my IBM PC Junior, because that's a language they teach to kids. And then also kind of neat, they have a graph. So you can see that Java in particular and C in particular have been dominant for decades. And C++ yeah, exactly. C and C++ are listed separately, but you can see that both Java and C are experiencing long-term decline because there is a lot of other things you can program in right now that are incredibly useful and in some ways a lot easier to program. Now, just because you're a compiled language doesn't mean you're more difficult to program in. Go is an incredibly beautiful language and easy to program in because it was written, this century, like literally this century. C was written last century in like 1960s.
Go is compiled?
Go is compiled. Okay, so and then just a restatement of my demo, compiled versus interpreted. You don't need to run the compiler in an interpreted language, but you do need the runtime. You need Python to be present. There are a lot of misconceptions about the differences between compiled and interpreted languages. One of the ones I hear all the time is that compiled languages are faster than interpreted languages. That is both true and false. It's because it's an oversimplification. If you were to say use the very powerful numerical scientific calculation software called NumPy, N-U-M-P-Y, which can do things like matrix math and handle large numerical data sets in Python, you are going to find that that is absolutely as fast as doing the same thing in C. And you want to know why? Because NumPy or NumPy or however you say it is written in C. It's written in C, but you get to use it from Python. And all of the really computationally intensive stuff in NumPy is done at the C level, so your Python code runs just as fast as C code would. In fact, one of the things that's really awesome about Python is how easy it is to plug C modules into Python and Python modules into C. If you want to see a really insane example of how that's done, you can look at my program that grades people's CS11M homeworks, where I use Python to interface with C to emulate Arduino. Interpreted programs, sometimes people call them scripts. Write me a Python script, not a Python program. In principle, a script and a program can be used interchangeably. What's a program? Well, it's a sequence of instructions for the machine to run that does something. Isn't that a script too? Yeah. The difference between a script and a program doesn't really amount to anything. At least not in the context of programming languages like Python, where you can do anything you could do in any other programming language. Oh, I want to talk about the exercises for just 1 second, then I'm going to show you how to compile. The exercises are meant to be done by hand. So if you have the physical book, that's great. The author, and if you had read the introduction, which maybe you did, specifically asks that you do not copy and paste. Why? Because one of the things that you're going to notice about me is that I can talk and program at the same time because most programming tasks are already preloaded into my fingers. I don't have to think about them. And that's because I've done it a lot. Like, programming is one of my favorite things to do. If I didn't have to make money, that's all I'd do. Don't tell my wife. I would cook dinner sometimes. And so most things I can just kind of get out with my fingers. And part of the point of the book is to get you that level of practice, which is good for a beginner. You're going to make mistakes when you don't copy and paste. That's also good. Because when you make mistakes, you're going to see what happens in Python when those mistakes get made, and you're going to learn to figure out where your mistake is.